Greetings, and welcome to week 2 of software engineering. Today we're going to be discussing constraining requirements. And requirements, very simply, is the what of the system. What is the system supposed to do? Last week we talked about process models, and now we're taking a step. I wouldn't say a step back, but it's a step that we're looking at the underneath. What are we going to use the process models for? And that jumps into requirements. We're going to talk about functional and non-functional requirements. We're going to discuss techniques for gathering requirements, interviews, surveys, observations. And we're going to talk about use cases and user stories that basically tell us how the system should act based on looking at how the system is going to be used. Writing precise software requirement specifications, we'll talk about that. It's a document that we need to keep track of all the requirements. And validating requirements and managing changes. How do we do that? We have to not just write them one time and everything's set. We have to actually maintain those requirements and keep them updated and make sure we're giving the user and the stakeholders what they're expecting out of their particular application. So, requirement, what is it? It's a software engineering. It's a requirements, a statement that defines what a system must do or a condition it must meet to satisfy the user's needs. Two things I want to highlight here: what the system must do, satisfying user needs. Those are the two main things in requirements. What is it to do, but what is it to do to satisfy the users? Not what it's to do to make it look slick. It's not what it's to do to make it quick. It's not what it's to do to make it right, okay, in the eyes of the tech individual. It is for the user. It's for the stakeholder. That's who will make the final determination as to whether the system did or did not meet the requirements. There's two types of requirements. There's system requirements, statements in natural language, plus diagram the services the system provides, and system requirements, a structured document setting out detailed descriptions of the system's functions, the services, the operational constraints. The key thing that most of the time comes out of system requirements is the operational constraints. That and also the aesthetics on how the application actually looks and feels. Defines what should be implemented, so that part of the contract between the client and the server, it is part of the contract. Stakeholders, I mentioned stakeholders as far as what we're doing, the what of the system should satisfy the users and the stakeholders. Stakeholders, any person that of the organization who's affected by the system in such a way so as to have a legitimate interest. Okay, that could be anyone. That could be the CEO of the company, or that can be the person in the kitchen on the kitchen staff who's using the application to look up students' student IDs. Anyone who has an interest into how the system eventually is going to evolve, that person is a system stakeholder. Functional versus non-functional requirements. Functional requirements, statements and services the system should provide, how the system should react to particular inputs, and how the system should behave in particular situations. Also, it may state what the system should not do. Where we're talking about requirements, this is the what that should happen. It can also be this is the what that should not happen. Okay. In developing those requirements. Non-functional requirements are constraints on the services or functions offered by the system, such as timing. I need a response in 500 milliseconds. A constraint on development process. This must be written in Java, or standards. I have standards with the company. So these things are the non-functional requirements that I have to consider when I'm building a system. both functional on the functional side, the use, and on the non-functional side. And it's more of, what is it beside the basic what it should do? What other additional functionality should the system have in? And you'll see a diagram here shortly that lists and tells us all the different possibilities for non-functional requirements. Okay, requirements in precision. Requirements are not absolute. Ambiguous requirements may be interpreted different ways. So that is one of the main problems with requirements, is making sure that the user who's going to be using the system and the tech or developer who's going to be writing the system are looking at the system in the same way. Okay. So this is just an example. User intention: search all the patient's names across all appointments in all clinics. Well, when the developer gets and they interpret it, they might say search for a patient name in an individual clinic. So what they're saying, we're going to choose the clinic and then we're going to search it. Two different things, both of them having to do with searching. Okay? But the interpretation of what the requirement was is different. Requirements have to be complete and consistent. Okay, so this is the most important, I think, right here. In practice, because system and environment complexity, it is impossible to produce a complete and consistent requirements document. We will never have a document that is perfect. Okay? We are striving to have a document that is as complete as and consistent as possible, given, number one, the cost, how much money we're throwing at it, the time, okay, how much time we're spending on it. Okay? So those two things are going to basically drive the completeness and consistency of the requirements of the document that we're going to be putting together. There are constraints we're going to be working under that's going to drive us as to what we're going to need to do. Here's the diagram we about for non-functional requirements. We're not going to go through all of these, but you can see, and they'll be available in your resources, but non-functional requirements, product requirements, external requirements, efficiency, environmental, accounting, various non-functional requirements that we may have to consider in our project, depending on what the project is and what we promise the stakeholders and the users that we would deliver. Requirements engineering process. These are the four things that a basic requirements engineering process goes through. And requirements engineering process is basically from the time that we create a requirement to the time we've satisfied the requirement. That is the process. So we're talking here, we're going to do requirement solicitation, where we're going to get the requirements. We're going to do requirements analysis, where we're going to look at the priority of the requirement and placing it where it should be as far as what we're going to do first, what we're going to do second. Requirements validation. Yes, we had requirements. Is it doing what we said it should be doing? Requirements management. Requirements change. They update. They need updating. Some requirements need to be dropped based on the fact that based on priorities, we're not going to be able to get to it. So there's a whole gambit of activities we have to have just to maintain and manage the requirements that we have. In practice, requirements engineering is an iterative activity in which processes are interleaved. Okay, so we might go to elicitation, do an analysis, and say, "Now we don't have all the requirements." So we have to go back to elicitation, get some more requirements, do an analysis, take that analysis, run through a validation. Something's not valid, right? Let's go back and analyze it, or maybe you have to go back and get some more requirements. So it's interleaved. It's not a one-step process that we're going to be going through. Here's a spiral model. We talked about a spiral model for process development. This is a spiral model for the requirements engineering process. Where we're starting, we're getting business requirements, doing a feasibility study. We're getting, based on a feasibility study, we're getting requirement solicitation. We're asking for requirements. We are creating requirement specifications from those. From that, we're going to be building some prototypes. Okay, we're doing system requirement solicitation, system requirement specification, and then basically coming out to reviews. So this is kind of a high level look at the requirement steps that we designated here, okay, in a spiral model form. Okay, problems with requirement solicitation, truism, okay? Stakeholders don't know what they want. And that is a basic fact of life that whenever you get a requirement from a user, don't be surprised at all, none. If you do it, you get the requirement, you design it, you get the specifications for it, and you give the user or stakeholder a prototype of what it's going to be doing, what it's going to be doing, and they come back saying, that's not quite what I thought it was going to be. That's not quite what I want. So part of the job of the systems engineer, okay, is to be able to take that information, do a prototype, but with the expectation, and this is everyone, with the expectation that what you're presenting as the solution to the problem for the user or for the stakeholder may not align with what they're thinking. Okay. Stakeholders express requirements in their own terms. We're going to be talking about that. One of the things that helps that is a glossary. Different stakeholders may have conflicting requirements. I have a stakeholder in Department A, stakeholder in Department B, and what they want is conflicting. Okay, so we have to resolve how we're going to resolve those conflicting requirements. Organization, political factors. Politics is not something you really want to do, but it's real. Okay, that you might have to go through politics of what the requirements that are going to be acceptable. Requirements change during the analysis process. That's just going back here. Okay, talk about here, going back here to the spiral model. We can be looking at having to reanalyze the requirements, and then, as we say, go analyze requirements, go back up, might have to elicit more requirements, depending on, how off we are with satisfying the customer or the user. Okay, so here are some of the activities. Requirements discovery is an elicitation activity. Requirements classification and organization. Prioritization and negotiation. Some of these things we're going to rehash in class. Okay, so you'll see it again. Especially just because that what we're doing here is we're going to be talking about what are the things that can happen with requirements. For example, once we classify a requirement, okay, we put it in a group, okay, we're going to find that how we classify so that we can, bottom line is determine that if we can't do it, if for some reason we cannot satisfy a requirement, then for example, what kind of priority are we going to put on it? What is going to determine whether we drop that requirement or whether we keep that requirement? So that's what we're getting into requirements classification. We're classifying them, we're organizing them, we're prioritizing them, and negotiation here, we're getting with the stakeholder and says, we can't do that. Can we do this? And that is the part of the negotiation process. Requirements classification organization, and then requirement specification. Requirements are documented and input to the next round of the spiral. Interviewing and elicitation activity. The key thing here, the types of interviews. It'll be closed interviews based on predetermined list of questions, or open interviews where various issues are explored by the stakeholder. Here, this depends on how you ask questions. If you're giving your questions, do you look up username? Okay, and that's a closed interview question. I want you to answer this specific question. Versus, what do you do to look up the username? That's open. This is going to generate more feedback from the interviewee than a closed. But sometimes we need to have specific information about closed interviews. So it's not saying that we don't do them, but open interviews are better in getting true requirements of what's coming in or what's going to be needed by the system. Effective interviewing, you have to be open-minded, avoid preconceived ideas. Don't go into an interview thinking that you know the answer. You're going into the interview to prompt the interviewee here, get discussions going as a springboard. You want to try to get the requirements from the user, from the stakeholder. That is the goal. Many times I must make that sometimes you go in and say, well, I know what the system's going to look like based on your experience. But that's not the case. We have to do the interview from a user perspective. Everything that we're driving for, everything we're building in the system is for the user, and we have to put it in a user perspective. Ethnography, this is basically a process where someone will sit down and actually look at what you do, or look at what the user or what the stakeholder does. There's no questions. That's just saying basically, I see them doing step A, step B, step C, step D. Yeah. And so you're basically building the requirements or some of the requirements that you're going to need for the new system by looking at what the user is doing on the old system. The main thing about this that is bad, that doesn't work, is that if you have something new that you want to put in the system, this is not going to work because you're not going to see them do it because it's new. So to get old requirements to make sure the system does what it did do, ethnography is a perfect way of doing that. But again, if it's something new that you're going to be building into the system, that is one of the flaws of this particular activity. Okay, user stories. Scenario is a structured form of a user story. They should include a description, starting situation. Okay, user story, let me. Okay. Now, what I want to do, I'm going to real quickly jump down to here. I should have put this slide first. A use case, okay, then the user story. But let's do it this way. Let's go back. A user story is just that. A user story is describing a process that's happening between a role, between a person or a system or a thing and the application. So what we're looking at with a user story is as a student, okay, I want to be able to look up my library books for online, okay? Now, just for an example, that is a user story. That is a requirement that we're putting into the system, and we're basically personifying it as a story of one of many stories, okay? So we're going to be creating a bunch of stories that describe what the system is going to be doing. So a scenario is a structured format user story. Basically what it's saying is here, I want a description of the starting situation, a description of normal flow of events, a description of what's could go wrong, information about other concurrent activities, and a description of state when the scenario finished. So again, these are the criteria that we're going to try to build in. And from this, you can give this to a user or to a stakeholder and says, hey, here's the processes that we're going to go through to satisfy X requirement. Here is Agile. This is a user story from the Agile perspective. And here it's a little more simpler, but it does lay out the same basic information. As a user, some type of user, I want to do some task so that I can achieve some goal. That's the story. That's the requirement. That's the requirement. Now, how can we take that requirement and accept it? How can we tell that we satisfy the requirement? What is the acceptance criteria? So here we're saying, given some condition, okay, given some condition, when some actions carried out, then a set of observational outcomes should occur. Okay. So let's see. As a student, I want to be able to look up my text for my class online so that I will be ready for class when the semester starts. Here's my acceptance criteria. When the semester starts, given that the semester has started, when I get into class, then I will have the textbook that I need in order to proceed with the class. So here's the requirement, and then here is the acceptance criteria. So yeah, the requirement was satisfied. There'll be other cases of other user stories that we're going through. So we've gone through several of them, and several of those are coming from your application that you will be building. Okay, use cases are a kind of scenario that are included in UML, United Markup Language. Unified Markup Language. I'm sorry, Unified Markup Language. Use cases identify the actors and the interaction and describes the interaction itself. A set of use cases describe all possible interactions with the system. All possible interactions. Okay, we want to get a significant number of interactions. We're may not get all of them, but we want to get as close as we possible to the full set of requirements that we need, or it's a full set of interactions. It's a high-level graphical model supplemented by detailed tabular descriptions, and we'll talk about the models a little later. Here's an example, and you can look at this. You can see the whole picture of your application in general. Okay, as far as here are the use cases, the medical receptions of use personal information, which goes to the manager, and they export and give statistics. Okay, so looking at each path, you can kind of determine what the system is going to look like. What are the use cases? These are the roles of the players: the manager, the doctor, the nurse, the medical receptionist. These are the activities: requesting patient, viewing records. So each one of these user stories are going to help us drive and make sure that what we have in the system meets the requirements of the user. Okay, software requirement specification. The software requirement specification is an official statement of what is required from system developers. It is a form, and I will be providing that form to all of you. It is a form that basically, if everybody uses the IEEE standard, all the requirement specifications that come out are going to look the same. Okay. So when you look at one, you should be able to find the same information that you're looking at another. Not a design, it's not a design document, it's a requirements document. Okay, what does the matter? Defines what is to be built before coding starts, serves as a contract between the client and developer, enables traceability, testing, scope, and reduces rework and ambiguity. So here's just, we're going to kind of list these, and I think some of your homework assignments has to do with the SRS providing this information. But we have, introduction, overall description, what are my functional requirements, what are my non-functional requirements, do I have any external requirements where I'm dependent on interfaces that aren't within my domain that I'm going to be building. Data and models, use case, user stories, system behavior, constraints, compliance. When I get all this information about a particular application that I'm building, I will have a very good picture from a requirements point of view as to what the system should do. Okay? And that's our goal. Okay? The software requirements specification is so that we can gather requirements, have them in one place. Okay? Everybody can go to the same place to look at it, look at the SRS, and be able to determine what the system should do. Here's functional requirements. The key thing here I just want to highlight is you're going to want to identify every requirement. You're going to give it an ID, okay, because this is going to be used in the traceability document that we're going to be talking about later. But every requirement should have an ID on it. Every non-functional requirement should have an ID. Do we have to use this exact format? No, no. You can use whatever identification format you would like, but be consistent. I mean, don't have a non-functional requirement 1 in a different format with the ID of non-functional requirement 2. So have it so that you're consistent in how you're basically labeling requirements and non-functional requirements and non-functional requirements. Okay, use case. Use case is the same way. When we create a use case, we want to put an ID on them. When we create a user story, we want to put an ID on them. Everything we build and put in the SRS, we want to have it identified by some identification ID. Okay, here's a traceability document. This is going to be a document that we're going to be using throughout the building of the application. And basically, there's 4 columns. There's a requirement ID, a description, a use case ID, and a test ID. And that's what's in a particular traceability document. So here, for example, we have functional requirement 3, approver can reject an event. Here's my use case ID, and here's my test ID. Now, even though we haven't created a test yet, this is a placeholder that says whenever we start testing, we need to make sure we have a test to test this particular functional requirement. And we're giving it an ID ahead of time. So we may not have what this exactly is now, but we will have it in, I think, by video 6. Okay, we'll have that to where we've identified these testing requirements. So traceability matrix. Keeping track of the requirements, the functional requirements, the non-functional requirements, and basically putting in this table everything that we're going to need to test to make sure that we've satisfied that requirement. Okay, requirement validation. This is basically the steps we're talking about from the requirements engineering, ensuring requirements reflect the stakeholder needs. If you didn't hear me say that 1,000 times just during the session, everything is based on what the user and what the stakeholder needs. That's what you're striving. Detects errors, omissions, and is a key part of software quality assurance. Validation versus verification. I've got them mixed up, and I'm sure you will before it's all over. Validation. Are we building the right product? We're validating whether we're building the right product. Verification is, are we building the product right? Validation, are we building the right product? Verification, are we building the product right? Validation focuses on customer needs. Verification focuses on technical correctness. Okay, the SRS, software requirements specification, is a validation tool. Are we producing the right product? Techniques for validating requirements, reviews and inspections, prototyping, where we build a pseudo application or a small piece of the application so that you actually visualize what the requirements are being presented. Test case deviation ensures testability, and checklists. This is where we're going to basically be when we define the test IDs. Okay. The test cases, we need to make sure that every requirement we have is testable. Example of validation checklists: correctness. Does the requirement reflect the user intent? clarity, make sure there's no unambiguous requirements in the document. Feasibility, can I implement it? I have a requirement. I need to make sure that I can actually do it, that it is feasible. And testability. Yeah, it's feasible, but there's no way I can test it. Okay. So feasibility and testability are things that you want to make sure when you look at your requirements, okay, you're able to do. Requirements evolve, okay, due to changing user needs. And yes, there will be changing user needs. There may be some frustration at times when the user changes what they want the system to do. That is one of the advantages of Agile. Agile is made so that it welcomes change. Other systems that are on, we talked about last time, for example, the spiral model or or any of the models that don't include Agile. Okay? They're basically based on plans. Okay? Stepping stones, okay, for example. Okay, so we have to basically be in a position that we can change things that the user wants, because this is going to happen. The user is going to want to change requirements. Other things could be regulatory. Okay? Regulatory updates that could change it. Technology advances. We're getting a new type of computer. Okay, so we need to make sure that our particular application works on that computer. Managing changes prevents scope creep. And we'll talk about scope creep because it happens in every application. That is where you're working with the user. The user says, okay, can we do this? I know we said we want this, but can you do this a little bit piecier? And then you do that, and then the next time they say, well, okay, that's good, but can you do a little bit of piecier? Okay. And so what happens is you start getting what we call scope creep, okay, where the application and requirements are getting bigger at small increments at a time, which can get to the point where you're going to find yourself where you can't satisfy the requirements because you don't have enough time, you don't have enough resources, because you had scope. Change control process. This is one of the pieces of SRS, okay, to make sure that whenever we change something in that document, we create a new version. That's just part of change control. Change request submitted, impact analysis performed on what that change is going to do. Reviewed by a certified board of the project determines whether changes are allowed or not allowed, and update the SRS version and communicate updates to the stakeholder. Okay, this is just an example, okay, of an SRS change. Some best practices: maintain version control SRS, document rationale of each change. Okay. And you'd be surprised, it's to have this type of information and have versions is almost a must, because if you don't keep versions of your particular document, you don't have any history. You can't say, well, we made this change, but we made this change because of situation A. Okay. If you don't have a document that has situation A in it, okay, you just lost it. You've lost the history. Okay, so you have to have a version every time you make a change. So if you need to go back and identify some piece of information from where maybe a change came from, you have it in a document. Okay? It is documented that you can go back to that particular version and see what was the overview of the system as far as what it's going to do at that time for that particular version. So in summary, validation ensures requirements meet the user needs. Software requirement specification provides a baseline for validation. Managing changes keeps the project aligned and consistent. Okay, that is our lecture on requirements. And we will be seeing you in class to kind of expound on this and seeing how this applies to your individual project. Okay. Everybody have a good one. Bye.